Welcome to the Drowsy Science channel, and hello. We're going to talk about one of the most uncommon discoveries of our time tonight. A new object that is traveling through our heavens has been discovered by astronomers. It is not a part of our solar system and is known as the Three-Eye Atlas. It originates elsewhere, a world far away from our own, another star. Only 2 of these visitors have ever been verified throughout history. Each barely lingered for a moment before disappearing once again into the shadows. A third has now come, and we have an opportunity to observe it more carefully this time. We can observe a fragment of another planetary system when it passes by our solar system for a brief period of time. We will be able to determine the object's composition, its duration of travel, and potentially provide information about the planets orbiting distant stars. I encourage you to like and subscribe if you like these serene investigations, or just leave a comment. It also makes it easier for others to find their way here. One drowsy person at a time. For now, though, let the day pass. As we discover the newest guest from the sky, let your body relax and come along with me. The beginnings of this tale are modest. There was only a sliver of light at first, barely noticeable. Automated sky surveys captured a little speck moving against the stars in early July 2025. It was nothing special on its own. However, the movement revealed a different narrative when astronomers compared the frames. This was neither a far-off galaxy nor a star. Something was moving, something closer. Initially, it could have been written off as just another comet or asteroid of the weakly kind. However, the figures didn't add up. It moved quickly, and its path's arc appeared strange. A few meticulous computations suggested more. There was no orbiting of the sun by the speck. It was just going through. The first indication of an interplanetary visitor was that faint movement, nearly lost in the clamor of the sky. Atlas, the asteroid terrestrial impact final alert system, including the telescope that detected this weak signal. Night after night, Atlas is designed to seek the skies for safety, rather than beauty. Its job is to locate anything that is traveling fast enough to eventually get close to Earth. Taking wide-field photos and searching for minute dots that change between exposures is how the system operates. It turns out that the majority of those dots are innocuous asteroids, silently orbiting the Sun. Occasionally, one might get close enough to attract notice, but every so often, something unfamiliar shows up. Atlas was the first to see a body whose movements did not seem familiar on that July evening. Instead, one of the most uncommon possibilities in contemporary astronomy has been discovered by a discovery mechanism that was intended to keep an eye out for danger. The night of July 1st, 2025, will be remembered for its routine rather than its drama. On their nightly routine, the Atlas telescopes above Hawaii were using motorized patients to sweep the starfields. It is challenging to spot faint moving objects in the cluttered sky close to the Milky Way's center. However, algorithms detected a faint dot that moved between frames among the many stars. The motion was sufficiently obvious to merit further investigation. It still seemed to be a background star to most onlookers. However, something about it caught the attention of people who had witnessed numerous such detections. In a matter of hours, astronomers in other places received the data and were asked to verify Atlas's findings. A pixel-sized dot had been added to the record, a dot whose actual nature would only be revealed via meticulous computation. The dot was initially categorized just like any other comet. C-2025P1 was its provisional name. But in astronomy, names matter. As things show their nature, they transform. This object was not looping back to the Sun according to calculations made with the new data. Rather, it followed an open hypo, which is a one-way route across the solar system. This insight resulted in a shift. An interstellar body was the new classification for the item. The name was changed to 3I 2025P1 Atlas. It was the third interstellar object ever found, according to the 3. The system that saw it first was honored by Atlas. Now, a series of letters and numbers represented something extraordinary. A visitor from beyond our star who was momentarily in our neighborhood. Anything that originates between the stars is referred to as interstellar. The majority of comets are frozen pieces that revolve in enormous loops that keep them attached to our star. Interstellar objects, however, are not the same. They are not dependent on the gravity of the sun, as evidenced by their direction and speed. They are aliens who were born somewhere else and drifted into the galaxy after being thrown there by their native systems. One is not coming back when it happens to go over our skies. This is the only time it will ever pass through. This uncommon category includes the Three-Eye Atlas. It is a piece of another story, not the story of our solar system. Seeing it is like catching a glimpse of the past. Its uniqueness, independence, and voyage over the vast regions between stars are all acknowledged by the term interstellar. There have only ever been 2 other confirmed interstellar objects in recorded history. 2017 saw the first appearance. Oumuamua, which means a messenger from afar arriving first, was its Hawaiian name. It seemed oddly elongated, but it had no tail, and it generated a never-ending discussion over what it actually was. The second in 2019 was Comet Boris, which had a sweeping tail and a bright coma, more like what we would expect. In 2025, the third Three-Eye Atlas will be released. Although 3 instances might not seem like much, astronomers see them as the start of a trend. Every one of them has been unique and provided a fresh viewpoint. The mystery grows with each new finding. Which fragments are making their way across the galaxy? How many go unnoticed? We now have enough samples for the first time to start addressing such questions. The astronomical world rapidly learned about the discovery. Although it didn't make news right away, observatories changed their schedules in a matter of hours. Both amateur and professional astronomers aimed their instruments toward the dim point of light. The excitement was constant rather than deafening. There was a focus, an awareness of how unique this opportunity was. The initial interstellar visitor had been too peculiar and brief to be completely comprehended. The second had been more intelligent, but it was still unclear. A third was now found in time for a thorough investigation to be organized. There was a sense of subdued urgency, just the realization that a window had opened and that, for a little moment, the universe was giving us a gift. No hurry, no worry. This discovery is significant not only because it is rare, but also because of what it stands for. It took billions of years for our solar system to form. It is not, however, isolated. Exchanges abound in the galaxy, pieces sent outward by star birth and floating until chance takes them near to one another. Every interstellar object is a sample from a nursery that we are unable to visit, a fragment. When one flies into our skies, it provides an opportunity to discover the composition, formation, and differences of different systems. Third, Atlas is not just a little comet. It is a messenger with the history of another star's fingerprints. Its arrival, according to the scientists, is like getting a parcel from the far side of the galaxy that can only be opened as it passes. Thus, we start this story with a weak signal on a computer screen rather than a spectacle. A single, nearly unnoticed dot has gained international attention. We'll see how that dot came to light in the upcoming chapters. A story unfolding in the sunlight, a chemistry that shocked onlookers, and a trajectory that verified its source far from the sun. We shall proceed at a leisurely pace because this is a story that develops gradually. A bit more wonder and clarity are added with each step. This is what counts for now. We have a visitor in our sky from another system, and we have the opportunity to witness it for a fleeting period in time. It's seldom easy to spot anything like 3 Atlas. Against a dense background, interstellar objects are small, dark, and swift. The hum of the sky usually drowns them out. The problem is that until a telescope detects their motion, they appear to be weak stars. Even still, the signal is weak and, in many studies, no more bright than the margin of error. Astronomers need to exercise caution. Motion can be mimicked by a single erroneous reading. However, a new narrative is revealed when several detections coincide. It takes perseverance, extensive field surveys, and the collaboration of observatories worldwide to file a faint wanderer. A data point is added with each frame. The image gets sharper every night. The reward is enormous, but the effort is quiet and careful. For a select few, the floating particles proved to be extrasolar visitors. The environment presented the first difficulty. Near the Milky Way's bright core, the three-eyed Atlas was found against one of the sky's busiest star fields. Every picture in that area is crowded with thousands of stars, with clusters and galaxies piled on top. It's like trying to identify a grain of shifting sand on a busy beach to detect motion here. It was made more difficult by the object's faintness. However, the signal was present, a consistent drift between frames that was impossible to replicate with a background star. Instead, it was revealed on the crowded field that might have concealed it. Because everything else was so fixed, the slight movement was quite noticeable. What appeared to be a misunderstanding proved to be the evidence astronomers required. In a sky of calm lights, a little dot moving purposefully. Larger tools were soon added to the search. Gemini South, a potent 80-meter telescope situated in the Andes of Chile, was among the first. The weak speck may be resolved into a finer point by Gemini's large mirrors, which could gather significantly more light than the Atlas survey cameras. Its findings verified that the thing was real, quantifiable, and not a mistake or artifact. Gemini's data improved the route with every night that went by. It became evident that this was no typical comet attracted to the Sun. The velocity was too high for gravity to support, and the orbit bent outward rather than inward. The evidence was growing. The traveler was interstellar. It was the responsibility of Gemini South to capture the first unclouded image that transformed a weak signal into a confirmed finding and turned doubt into confidence. As the days went by, something changed. It was no longer merely a twinkle of light. A thin but distinct haze started to build around it. As sunshine warmed the cold surface, the cloud of gas and particles released this coma. Soon after, a thin tail that was pointing away from the Sun started to extend. This was the moment when the discovery really came to life for a lot of astronomers. It was now a comet in motion, displaying the well-known indicators of activity rather than merely a point on a chart. That tail demonstrated the presence of volatile ices, the kind that melt in the presence of heat, in the three-eye Atlas. Although its trajectory indicated that it was not a local body, it was acting like a typical comet. The most obvious indication of its nature was that it was a comet from a different star system. It takes multiple telescopes to confirm an interplanetary object. Observations from all across the world joined in within days. Photos came in from South Africa, Spain, Hawaii, and Chile. The outcome was the same for all of them: a tail extending into space, a dim core, and a forming coma. There was less uncertainty due to the independent confirmations. This wasn't a one-time occurrence or an illusion. Across instruments and continents, the data were consistent. The orbit became sharper with each subsequent image, honing the hyperbolic trajectory that distinguished it. The scientific community advanced swiftly and steadily, without much fanfare. They were aware of how uncommon these chances were. The confirming photos created an unshakable consensus. This was spectacular, and it was real. The Hubble Space Telescope, one of the most significant additions, followed. Hubble was able to take a clearer picture from its location above Earth's atmosphere, free from weather and air disturbances. Details that were not visible to ground-based telescopes were revealed by its crisp photos. It became easier to see the structure of the coma, the alignment of the tail, and the brightness of the nucleus. Hubble's affirmation was more than a mere token gesture. It offered information that would serve as a guide for future research, establishing standards for composition and brightness. The three-eye Atlas became increasingly accurate when Hubble's eyes were included in the endeavor. The small blip that had been the interstellar traveler was no more. One of humanity's most reliable space instruments catalogued and verified the comet, which had been thoroughly observed. In those initial weeks, a recognizable shape appeared. The feature that characterizes a comet is a bright coma encircled by a thin, extended tail. This distinguished the initial interstellar visitor, or MOA, who had not displayed any such characteristics, from the three-eyed Atlas. In a way, it was comforting to see a tail. It indicated that astronomers were able to examine it with the same methods that have been used for generations to analyze comets. It was possible to track the chemistry, the dust, and the outgassing. Although it came from a faraway place, its behavior was familiar. It was captivating because of that combination of familiarity and strangeness. There was more to this intergalactic rock than that. It was an active comet that behaved similarly to our own, but it had the structure and history of another star system written on it. Comparisons were unavoidable. Astronomers recalled the 2019 discovery of the interstellar comet Boris. In addition, Boris had developed a brilliant coma and tail that resembled comets in our solar system. Echoes of that incident were found in 3 atlases. Both displayed traditional characteristics. Both revealed that comet-like entities do, in fact, move between stars and carry volatile ices. However, the 3 atlases provided something Boris was unable to: further caution. There had been little time for observation as Boris had hurried by. Atlas, on the other hand, had been discovered early enough to enable months of meticulous preparation. As a result, there were more telescopes, instruments, and chances to thoroughly examine its composition. In many respects, it was what astronomers had hoped would happen: an interstellar comet. Nevertheless, Amour-Amour's memory persisted. Long, skinny, and oddly tumbling without a tail, that first intergalactic visitor had been perplexing. Its nature had been the subject of frenzied speculation. 3 Atlas seemed simple in comparison to that. It appeared to be a comet. Its comet-like behavior and trajectory made its interplanetary origin obvious. Atlas provided clarification where Muammu had provided more questions than answers, but the riddle was simply made more complex by the contrast. Why had the first 2 arrivals from space been so dissimilar? Did we underestimate the diversity of interstellar bodies? If this is the case, Atlas may just be one of many categories. The study of Atlas was placed in a larger context by the contrast between the luminous comet of 2025 and the odd shard of 2017, an expanding list of the galaxy's nomads. After those initial observations, there was no question left. Numerous telescopes worldwide and above the atmosphere were tracking the dim dot which had developed into a well-studied comet. Everyone could see its activity, its course was verified, and its interstellar nature was assured. It was a relief to feel certain. Now, astronomers could proceed with assurance, organizing in-depth analyses of its composition and monitoring its solar system trajectory. This was the time of arrival for the larger community. The finding was no longer merely a chart with numbers on it. It was evident, real, and indisputable. Our sky has been visited by a wanderer from another star system, and we had the time and the resources to really see it this time. There was a surprise at the start of the 3I Atlas path calculation. Unlike other comets, its orbit did not narrow. Rather, a hyperbola, an open curve that arcs around the Sun and extends back out into space, was depicted by the numbers. This is an interstellar visitor's mathematical signature. The object was moving too quickly to be captured, according to the computations. It would never be claimed by gravity, but it would bend its course. After it passed, it would bring it back into the galaxy and continue indefinitely. Such an orbit is exciting to astronomers. It is numerical evidence that the item is not appropriate for this location. There is only one meaning for a hyperbolic orbit. This is a visitor from a different system who passes across our skies once before vanishing into the night. The perihelion, the comet's closest point to the Sun, is frequently used by astronomers to characterize the comet's trajectory. There is one in every orbit, whether it is open or closed. That would be the most active and brightest time in the three-eye atlas. The moment when its concealed ices would boil into vapor due to the warmth of the sun. Perihelion, the height of a comet's visibility, is more than just a location in space. It's a point in time. It is particularly important for an interstellar visitor, as it is the only opportunity to witness its actual nature. Then, as it moves away, the features disappear and the light dims. Astronomers are given a deadline by perihelion. The chance won't come around again, therefore everything needs to be prepared before it gets close. Three-eye atlas will reach its perihelion on October 30th, 2025. It will sweep closest to the Sun on that day, passing within a safe but noticeable range. When the gases that have been trapped inside for billions of years explode into space, creating the coma and tail in full view, this will be the most active time. Carefully directed instruments on Earth and in orbit will record the light spectrum, measure the composition, and track changes hourly. The day is already marked on astronomers' plans. Before the comet disappears back into the night, this will be the best chance to see it for what it really is. For a once-in-a-lifetime trip, October 30th will mark the pinnacle of its fleeting performance. The comet will pass close to the Sun, but it won't go very close to Earth on its trajectory. At its closest, it will still be millions of kilometers away, far more distant than the Moon, and even further away than the typical comets that pass close to Earth. However, it is still regarded as a close brush in astronomy. It is close enough for detailed examination by earthly telescopes. It's close enough for casual onlookers to catch a glimpse of it in the dark. Although it is far away, the approach is not. It is close enough to thrill both sky observers and scientists without endangering anyone. The brush will be invisible to the majority of us. However, it will be a unique and valuable experience for the instruments pointed skyward. There will be a time of proximity for Mars too. Three-eye atlas will get within a reasonable distance of the red planet as it rounds the Sun. Close enough to be interesting, but not close enough for drama. It might even be possible for orbiters near Mars to point their equipment in its direction, providing a view from a different planet. Such alignments are sometimes possible due to the solar system's shape. They also add an additional layer of data when they happen. This comet will be monitored from Earth, from space telescopes, and possibly from Mars. Each point of view contributes to the puzzle, creating a more complete picture of the trip of the interplanetary visitor. Even if Mars doesn't see a spectacular, its instruments might be able to tell the tale. The topic of whether the three-eye atlas was dangerous was one of the first ones raised. Since extraterrestrial objects move quickly, a collision would be disastrous. However, calculations soon ruled that out. It passed the Earth and the inner planets safely in its orbit. The range of concern is still distant from its closest approach. The majority of comets that come from within our own solar system actually pass much closer than this one will. The enthusiasm surrounding the three-eye atlas is not defensive, rather it is scientific. Without the threat of danger, astronomers can concentrate fully on learning from it. This assurance contributes to the rarity of the gift. Knowing that it will pass silently and carry on, we can examine a piece of another system with interest rather than dread. One of the characteristics that sets the three-eye atlas apart is its speed. It travels through space at tens of kilometers per second, even when it is at its slowest, close to the curve of perihelion. That is a lot faster than comets that are attached to the Sun, whose orbits can cause them to move more slowly as they ascend. Atlas is free and moving forward without stopping thanks to its momentum. This speed is both a problem and a clue for astronomers. Due to the comet's nightly position changes, observation becomes challenging. However, it also verifies where it came from. On such a steep slope, only an intergalactic traveler would be able to move that fast. Its speed serves as a reminder of how far it has traveled. The protracted voyage that started around another star and has now momentarily brought it into our line of sight. It takes accuracy to forecast such an object's trajectory. Every positional measurement is entered into models that take into consideration the quantities poured, solar pressure, and the drag of gases generated during warming. The trajectory gets sharper with every successive data point. Transforming indistinct dots on a screen into a future map is the art of celestial mechanics. Because there is no extensive history of previous orbits to inform the computations, the process is significantly more difficult for interstellar objects. Everything has to be inferred from the limited amount of time for observations. Astronomers, however, gained confidence in a matter of weeks. They could determine when and where to look, forecast its brightness, and map out its future trajectory. Though short, the road was no longer mysterious. Following perihelion, the narrative will start to wane. The gases will level out. The nucleus will return to the cold, and the tail will get weaker. Telescopes will follow it every night as it gets a little dimmer in the sky and farther away from the sun. This is both a sad and a fruitful time for astronomers. The spectacle fades, but the data persists. It serves as a reminder of how fleeting these kinds of events are as we watch it fade. We are not allowed to keep the item. It moves on after passing through and leaving its record. Its legacy, however, will endure in the pictures, the spectra, the computations, and the recollections of those who examined it, despite its fading. It's part of the rhythm of discovery to watch it vanish. Ultimately, the time frame is short. Only months will elapse between its initial discovery and eventual disappearance. The time spent with us is merely a pause for an object that has traveled for millions, if not billions, of years. That's why every observation is so valuable. Each night of data represents a moment in time that will never come again. It will disappear into the galaxy after 3i Atlas is gone, probably never to be seen again. The records we maintain, the research we publish, and the recollections of this generation of astronomers will all bear witness to its passage. Its visit serves as a reminder of the size of the cosmos and the rarity of seeing even the smallest passage of its inhabitants. The comet's appearance drastically alters as it gets closer to the Sun. It appears at first to be merely a faint dot, a frozen core of ice and rock. However, when it is exposed to sunlight, the outer layers start to sublimate, converting solid ice directly into gas. Dust grains accompany that gas as it escapes into space. The coma is a fuzzy environment that develops around the nucleus. The coma is thin, transient, and continuously renewed by new material bubbling off the surface, in contrast to a planet's atmosphere. Sunlight stimulates the gas molecules and scatters off the dust, which is why it glows. The coma serves as a diagnostic tool for astronomers. Its brightness and size indicate the amount of material the comet is losing. Its composition also reveals the types of ices that are included within. The coma is more than just a characteristic of an interstellar comet. It is the first authentic hint as to where it came from. This change has a straightforward trigger. Sunlight. The energy of the sun can warm a comet's surface sufficiently to cause its ices to melt, even at very long distances. Every substance has a different threshold, including water, ice, carbon dioxide, and carbon monoxide. Even distant from the sun, some evaporate readily, some need greater heat. The early activity in the case of 3i Atlas indicated the presence of volatile ices close to the surface. Jets of gas started to emerge as it approached the inner solar system, raising particles and producing the surrounding glow. This is a mild, violent procedure. Violent due to the fast speed at which gases erupt into space. Gentle because only a tiny coating is lost, allowing the comet to continue drifting intact. The sculptor is sunlight, which creates patterns of activity on the nucleus and leaves a transient layer of dust and gas in its wake. An essential component of the spectacle is the dust. Rock and carbon grains are carried outward, suspended in the expanding coma as the comet's ices sublimate. This dust is pushed by the solar wind, the sun's continuous flow of charged particles, which sweeps it into a long, thin structure. The most recognizable aspect of a comet is its dust trail. The dust shines mostly through reflecting sunlight, in contrast to gases, which glow in different hues depending on their makeup. It is the cause of the golden or white streaks seen on many comets. The dust tail, containing familiar components despite its foreign origin, was an early indication to 3I Atlas that the object was active. Every dust particle, silently floating on the solar breeze, is a piece of another solar system that has been liberated into our own. The direction of comet stories is one of their most intriguing features. People frequently see the comet's tails following it like exhaust, trailing behind it. In actuality, however, tails point away from the sun rather than behind the comet's trajectory. Regardless of the comet's direction, the solar wind is to blame for the outflow of gas and dust. This implies that the tail of the three-eyed Atlas may occasionally point ahead of its course, as if it were leading the way as it rounds the sun. Although this appears odd to the naked eye, astronomers expect it. The tail's orientation is like a compass needle, always pointing in the direction of the sun's energy flow. It serves as a reminder that comets are active objects. The influences in their environment continuously mold them. Their characteristics indicate the unseen forces of space. 3 Atlas's coma widened and its tail extended farther into space as the weeks went on. A veil of gas shimmering in reflected light was observed. Tens of thousands of kilometers across, a cloud. It was subtle but distinct. A nucleus that is much too tiny to resolve directly was surrounded by a halo. Despite its small center, the curtain gave the comet a sense of scale and presence. It was the first opportunity for astronomers to examine the gases emitted and use their spectrum characteristics to identify chemicals. It served as visual confirmation for skywatchers. This was a living comet reacting to the sun, not merely a dot of light. Its identity, the shroud it wore while it traveled across our skies, was the shimmering veil. Sunlight unlocked the ice hidden beneath, revealing it in the open for a short season. Comets can happen at any time. Others held stable, gradually becoming brighter as they got closer to the sun. Others burst abruptly, their light fading as pockets of gas beneath the surface burst outward. Overnight, these eruptions have the power to turn a dim comet into a visible spectacle. The issue of stability hovered over the 3I Atlas. Would it break apart like previous brittle comets have, or would it act like Boris, stable and dependable? Early signs suggested it was holding together, its activity gradual and its brightening consistent. Yet, no one could say for sure. Comets are fragile, and interstellar comets may be even more so. Each observation was scrutinized intently, not simply for the data it provided, but for any sign of unexpected shift. As a reminder that these guests don't follow a script, the tension was created by striking a balance between stability and outburst. Soon after, astronomers started contrasting Atlas's tail's brightness with that of well-known comets. It was dim, but not particularly so for a body so far away. The amount of dust and gas a comet emits, as well as how reflective those particles are, is measured by brightness. Researchers were able to assess the size of the nucleus and the pace of activity by monitoring changes night after night. 3 Atlas was a little comet, neither the brightest nor the faintest of the decade. However, its origin, not its size, was what made it significant. The greatest spectacles from nearby comets are not as significant as even a little story from a different star system. Its chemistry was visible. It was brilliant enough to examine, and it reminded us that light from extraterrestrial ices was now flooding across our senses. Professional astronomers were not the only ones who observed. Small telescopes were trained on the faint blur by amateur skywatchers who joined the effort. The comet might be seen by trained observers under ideal circumstances, away from the lights of the city. Its tiny tail might be seen faintly arching against the star field in long exposure photos. Every picture that was posted online increased the feeling of involvement. Light that had departed an intergalactic fragment was being captured by people with simple equipment all around the world. Comet science has always included amateur participation, and Atlas was no exception. Large observatories may have dominated the data, but anyone with patience and a clear sky could enjoy seeing it. Many saw Atlas's radiance as a way to connect personally with something that existed outside of our reality. The story of a comet has an indisputable poetic quality. It is the observable evidence of ice melting into vapor, dust being propelled into space, and stuff being shaped into a bright flag by sunlight and solar wind. For a short time, each story is one of the most exquisite views in the sky, but it will fade as the humor fades. The story has more weight because it is a free map. It is the remnant of a material plume that previously encircled a far-off sun, a piece of another star system. It is a history written in light to see it glowing now. The poetry is not in metaphor. Rather, it is a line of gas and dust that is apparent to our eyes and stretches beyond space, telling the tale of a world we will never see. The discovery was undeniable by the time Atlas, Coma, and Tail were fully unveiled. This wasn't just a collection of orbital calculations or a statistical anomaly. It was palpable, visible, and acting like a comic book. Its tail served as a flag that was raised in the sunshine to inform onlookers of its nature. That flag simultaneously communicated two things. I'm not from here. I'm a comet. The assurance of its identification and the awe of its origin were concealed in its radiance. For all the world to see, the dim smudge that started out as a single moving dot had grown into a comet. The fact that our solar system is not isolated was further confirmed by that glistening spectacle. That guests actually come, and that occasionally the cosmos allows us to see them up close before they die. Astronomers look at more than just comets' orbits and brightness while studying them. They pay particular attention to their chemistry. A comet is a frozen archive that contains dust and ice that maintain the circumstances of the formation site. Scientists can determine the ratios of gases like water, carbon dioxide, and carbon monoxide by looking at what evaporates into its coma. Each provides information on the temperature, distance from the parent star, and elemental composition. This chemical fingerprint is crucial for interstellar comets. We can't get any closer to holding a sample from a different planetary system than this. A faint smudge of light becomes a fragment of cosmic history due to chemistry. Each molecule discovered advances our knowledge of planet formation. Not here, but all throughout the galaxy. One of the most crucial instruments for researching the three atlases was the James Webb Space Telescope. Webb's infrared devices are specifically designed to find even the smallest gas remnants in space. The coma and tail are visible to humans, but the composition of those clouds is revealed by infrared light. The way that different molecules absorb and release heat allows Webbs to distinguish their signatures, even at long distances. This capacity gave Atlas the opportunity to measure the types of ices exiting as it warmed and to look directly into its chemistry. From such a distance, no other instrument could offer such detail. Astronomers were given the first clear view of the comet's extraterrestrial makeup thanks to Webb, which allowed them to see past its brightness and into the building blocks that were trapped inside. Both excitement and surprise were present in the first 3I Atlas spectra. Its coma's light was broken down into its individual wavelengths, revealing distinct lines that indicated the existence of well-known chemicals. Naturally, there was water vapor. Other lines, however, were more noticeable than expected. Specifically, the amount of carbon dioxide was higher than that of numerous comets in our own system. Not only was the existence of these gases surprising, but so were their relative potencies. The averages from comets that were born around the Sun did not meet the ratios. This was the most useful result for scientists. It indicated that the chemical tail of another system was actually being carried by the three-eyed Atlas. Its discrepancies were not noise, but rather an indication of circumstances that differed from those in our own cosmic vicinity. Carbon dioxide swiftly emerged as one of the three IMAP's distinguishing characteristics. Large volumes of CO2 were emitted, as the comet had warned, filling the coma and driving a lot of its activity. Carbon dioxide is a prevalent element in our atmosphere and climate on Earth. Its quantity varies greatly among comets. The levels were startling for Atlas. This implied that the comet developed in an area rich in ices that contain carbon in its home system. Additionally, because CO2 sublimates more readily than water ice, its activity might be greatly stimulated, even at great distances from the Sun. This abundance provided astronomers with a clear indication of the environment in which it originated, one that was both rich enough to trap significant amounts of carbon dioxide in its core and cold enough to freeze it. The ratio of carbon dioxide to water in the comet's emissions was one of the most important figures that scientists looked at. This ratio often falls within a specific range in comets in our solar system, which reflects the early solar nebula conditions. Atlas had a different ratio that was notably higher. This was a definite signal, not a slight oscillation. It implied that comets that develop around other stars may have different chemistries that are influenced by their own special gas and dust disks. Interstellar comets are important because of these distinctions. They demonstrate that there are differences in the formula for planets and tiny bodies. By measuring these variations, we can have a better idea of how varied planetary systems can be. One of Atlas's most revealing fingerprints is the CO2 to H2O ratio. Despite being less common, carbon monoxide had its own importance. At extremely low temperatures, SeO sublimates. Therefore, the circumstances in the coldest regions of a planetary system are revealed by its presence. The discovery of CO in Atlas indicated that some of its ices had survived exposure to extremely cold temperatures. Its probable birthplace was constrained by this feature. It must have originated in an area where even the most volatile ices could solidify, distant from its star. The discovery of CO was like discovering a time capsule from the edge of another planetary disk, according to astronomers, with the mark of a world that might have resembled the extreme outer regions of our own solar system. It was evidence that Atlas was not only interstellar in travel, but also interstellar in chemistry. Comparisons with our own comets started as soon as Atlas's chemical was understood. Though there were some minor variations, Boris, the 2019 interstellar comet, has demonstrated some resemblance to local comets. Atlas's chemical ratios, however, displayed more pronounced changes. It stood out against the comets of the solar system. This was a perfect illustration of the diversity of planetary systems, just what astronomers had hoped for. Atlas emphasized the distinctions, even if Boros had proposed some commonalities. Collectively, they demonstrated the irregularity of interstellar comets. Each has its own disk of material and its own star that shapes it. By contrasting them, we may better comprehend how planets and comets form, not as a singular narrative, but as numerous entities dispersed around the galaxy. There was more to the chemistry than just gases. Their story was also told via dust grains that Atlas emitted. Astronomers may determine the magnitude and makeup of the dust by examining the way light scattered across the coma. Some of the granules were as small as particles of smoke. Some were bigger, resembling fine sand. The mixture changed the comet's light color, providing hints about the minerals that were trapped inside. Dust analysis is delicate and necessitates precise modeling in addition to spectroscopy. Nonetheless, even this scant information is instructive. Every particle of dust was formerly a solid globe circling another star. The grains were now messengers, conveyed into our solar system. Their attributes described conditions that existed light years and billions of years ago. Compared to gas, dust is less dramatic. However, it is equally telling. Dust and gas combine to form the complete image of an extraterrestrial comet. Atlas's rapid global chemical conformation was one of its most impressive features. It was the target of instruments from observatories all across the world, from Europe to Hawaii to Chile. Data flooded in, frequently shared nearly instantly. The CO2, H2O, and CO signatures were verified by each team. Each made improvements, refining the ratios and lowering uncertainty. No single telescope had to bear the weight thanks to the international cooperation. It also demonstrated the power of contemporary astronomy. A synchronized network across continents might study in detail such a rare event. This collaborative effort provided assurance that the chemistry was genuine and not the result of a single instrument's error. One of the year's most extensively cross-checked results was the chemical fingerprint of 3 ILAs. Atlas had transformed from a dim speck of light to a fully profiled interstellar visitor by the end of its chemical analysis. Its ratios were compared, its gases were recognized, and its dust was quantified. In its story, each line in its spectrum became a sentence that explained its formation and the message it delivered throughout the galaxy. The comet's structure and history had been uncovered by chemistry. Humanity had never been this close to directly sampling another planetary system. The data persisted, but the comet itself would die. A collection of long frozen molecules that have been resurrected in our skies and encoded into our equipment. The answer we were looking for was in its chemistry. Evidence that the galaxy has a wealth of world-building recipes, some of which are momentarily within our grasp. There are differences throughout the Milky Way. Every neighborhood in this enormous spiral galaxy has a unique history. The thin disk that contains the majority of the bright stars and gas clouds is the one closest to us. New stars are still forming in this dynamic, thriving area. It is surrounded by the thick disk, which is older, less crowded, and full of old stars from the galaxy's early years. The halo, which is sparsely populated with star clusters and streams from long-ago mergers, is located beyond that. Although the origin of the 3I Atlas is unknown, their orbit around the solar system provides insight into their broader background. Given its speed and trajectory, it appears to be from an earlier, more tranquil region of the Milky Way rather than the thin disk where the Sun is located. It has weight just because of that reality. The dense disk is referred to by astronomers as the galaxy's fossil record. Stars that are older have fewer heavy elements and are dispersed over a larger vertical band above and below the Milky Way's plane can be found there. It does not collaborate with star formation like the thin disk does. Rather, it is an area of stability where older stars move more slowly and puff up. The 3I Atlas bears the imprint of that ancient population if it is indeed derived from the thick disk. Conditions that existed billions of years before the Sun itself began may be reflected in its chemistry, ices, and even dust. Although it is not the galaxy's brightest region, the thick disk is among its oldest. Items from this area are messengers from a period long before our own neighborhood was established. It is astounding to consider that the 3I map might be older than the Sun. Our star is roughly 4. By human terms, it is already ancient, 6 billion years old. However, there are stars and systems in the dense disk that could be at least twice as old. Its ice is concentrated in a protoplanetary disk long before Earth even existed, if Atos was born there. This Voyager is more than just an interstellar one. It might be a remnant of a previous era in the galaxy's history. Studying it is like grasping a piece of ancient history, a record from a long time ago, not simply a distant one. There aren't many items that can directly connect us to the past like this. Every molecule in its coma is a piece of evidence that hasn't altered since the time before our Sun was lit. Although the numbers may seem abstract when discussing billions of years, their meaning is obvious. Stars are created, grow, and die throughout these time spans. Whole planetary systems come into being and then disappear. New structures are created when galaxies collide. Atlas's continued existence after billions of years indicates that it has withstood cosmic upheavals unharmed. It hasn't been eaten by bigger bodies, burned by stars, or broken in collisions. It has just moved across the cosmos, cold and unaltered. Its value stems in part from its survival. It is more than just a holdover from a previous system. It has survived the passage of time. Its existence is inscribed with billions of years. In a body small enough to go unnoticed until today, an uninterrupted chain of history has been preserved. What brought it into interstellar space? Ejection is the solution. Giant planets frequently scatter smaller bodies in the early stages of planetary systems. Comets are propelled outward by their gravity, occasionally into new orbits and other times completely outside the orbit of their star. Each system has the potential to fling billions of such items into a drift. Atlas most likely was one of them. It was pushed and tugged until a huge planet threw it into interstellar night after it was born in the outer limits of a young star disk. Its relationship with its home star was permanently severed at that point. After that, it was free to roam anywhere, simply bringing with it the structure and chemistry it had picked up in its origin. That forceful, determined thrust marked the beginning of its interplanetary journey. After being set free, Atlas moved into the interstellar night's leisurely journey. It floated through the gaps between stars for billions of years. There is little that can be done to alter that vacuum. Its ices remained frozen solid in the cold. It was too far away to be influenced by a single star. It merely crossed the galaxy in silence, its momentum steady, unhurried, and unaffected. It was preserved by the nothingness. As a result, galaxies collided and stars altered. Atlas survived unchanged. None of it changed its course, even if it might have gone through areas formed by old supernova or diffuse clouds of gas. Its worth is partly derived from its leisurely journey. It is more than merely a piece of another system. For unimaginable centuries, this fragment has faithfully conveyed its message. However, interactions can happen even in interstellar space. Clusters separate, stars shift, and occasionally two systems approach close enough to perturb their comets. Atlas might have experienced the pull of passing stars over billions of years, each one slightly changing its path. These interactions are hard to track down. Every star in the galaxy is moving, making it dynamic. Among the millions of potential stars, the one that gave birth to Atlas is now lost. The comet's voyage is a record of innumerable encounters, the majority of which are too subtle to be recognized. It might have been moved toward our part of the galaxy by stellar flybys, which ultimately led it into the Sun's vicinity. We see it now rather than innumerable other concealed fragments because of the unpredictability of those encounters. Despite all of our computations, we might never be able to determine the true origin of Atlas. Its history is too lengthy, and its route has been twisted too often. Even minor uncertainties add up to impossibility over billions of years. Its overall origin can be modeled, but we are unable to pinpoint a specific residence. That is part of its beauty, according to many astronomers. With only its chemistry as proof, it continues to function as a messenger without an address. It is universal due to its anonymity. Atlas is linked to the galaxy's overall narrative rather than just one particular one. Any one of 1,000 suns could have been the source. We are reminded of the interconnectedness of all systems by that uncertainty. Its home is not a single star in the Milky Way, but the Milky Way itself. Statistics can provide clues even in the absence of a clear home star. Membership in the thick disk is suggested by Atlas's velocity, orbital tilt, and entry direction. This is probability rather than proof. This theory is supported by the fact that it differs chemically from comets in the solar system, indicating that it evolved in a colder, older environment. Astronomers want to improve these estimates by comparing a large number of these interstellar particles. A survey of comets from all throughout the cosmos, each one contributes to an expanding sample. Patterns will show up over time. Atlas already supports the idea that interstellar comets originate from a variety of sources, mirroring the various settings in which planets and stars form. Although it is statistical reasoning and not proof, it is sufficient to increase our understanding of the galaxy's diversity. 3I Atlas is depicted at the end of Act 5 not just as a comet, but also as a traveler bearing the memories of its birthplace. It was created in the nursery of another star, dispersed throughout the galaxy and kept intact for billions of years. It passed stars we cannot identify and traveled through areas we cannot map before finally coming close to our Sun. Its migration spans both time and space, taking it from one galaxy neighborhood to another on a cosmic scale. Even if we don't quite know where it came from, we still find it amazing. It is a piece of the long-gone system that has been faithfully maintained up to this point. Its journey serves as a reminder that migration is not limited to living things. It is inherent to matter that it drifts through the Milky Way indefinitely. A silent but resolute race began with the discovery of the 3I Atlas. Every hour was important after the thought point was raised. Interstellar guests don't wait for our convenience and travel swiftly. In order to fit in quick observations in between other projects, observers frantically rearranged their schedules. The first objective was straightforward: verify the odd orbit of the item. Then the task became bigger. Before the comet becomes faint once more, record as much information as you can. Teams from different continents worked together in almost real time, exchanging early plots, updating each other, and honing predictions. It was not a traditional competition. The realization that everyone was racing against the same time created a collective exhilaration. The race was to maintain the opportunity, not to claim the discovery. It had been offered by the college. Now humanity had to pay attention, swiftly yet cautiously, before it vanished. It takes a careful dance to coordinate telescopes all over the planet. No observatory can keep a constant eye on the sky. Night falls at different times, the Earth revolves, and clouds roll in. Astronomers used a global network to monitor a comet that was moving quickly, similar to the 3-eyed Atlas. The thing ascended in one place and set in another. Colleagues in Spain could receive it from observers in Chile and send it on to observers in Hawaii. Like a relay race, the data traveled the entire world in a continuous chain. The orbit was updated with every fresh set of coordinates thanks to software that assisted in combining the observations. Cooperation enabled what may have been a brief peak to turn into a constant watch. Few natural occurrences can evoke the degree of coordination that this global endeavor prompted, even though the comet itself was unaware of it. Of all the tools used, the Hubble Space Telescope was particularly significant. It could observe the comet without the air blur, since it was suspended above Earth's atmosphere. Although Hubble had already contributed to the confirmation of the existence of the 3I Atlas, its ongoing observations held out the possibility of more. Its keen vision could trace jets and measure brightness with unparalleled accuracy, resolving the comet's structure. There was a commonality among the three finds because Hubble had previously examined the previous interstellar visitors. It provided depth and clarity to Atlas, revealing subtle details that ground-based telescopes could overlook. Hubble's participation was both useful and significant to astronomers. It demonstrated how equipment above Earth can increase our reach into the cosmos and connected the study of Atlas to a long history of discoveries. On the ground, excitement was growing for the Vera C. Rubin Observatory in Chile, another instrument. Rubin, which was still getting ready for its first comprehensive surveys, was intended to use a huge camera to take deep photos while scanning the entire visible sky every few nights. Its goal is to monitor changes so that the universe can be seen moving. Rubin predicts earlier detection for interstellar visitors, allowing scientists more time to get ready. Astronomers could only view Atlas for a few months before the comet vanished. Future visitors could be discovered years ahead of time with Rubin, providing an opportunity to schedule spacecraft missions. During Atlas passage, Reuben was not yet completely online, but its promise was evident. This finding provided a sneak peek at potential future developments. Reuben may be the first to notice another interplanetary traveler approaching. The 3I Atlas case demonstrated the importance of early identification. As comets get closer to the Sun, they get brighter. However, they also go more quickly, slicing by before telescopes can pick up much information. Others learned how to spot subtle molecular traces by working with the spectra. These encounters went beyond simple intellectual pursuits. They had first-hand involvement in a once-in-a-lifetime occasion. Atlas served as a reminder to students just starting their careers of the initial motivation for their decision to pursue astronomy. It was both inspiring and humbling to have the opportunity to help with a finding of this magnitude, a turning point that could influence their work for decades to come. There was also the role of amateur astronomers. Skilled watchers worldwide tracked the three-eyed Atlas as it brightened using simple telescopes and contemporary digital cameras. Sometimes, before expert telescopes could confirm changes, their long exposure photos showed its faint tail. There was a feeling of community as a result of these photos being shared on internet forums and communities. Individuals from many nations checked each other's work, compared notes, and contributed to the body of knowledge. The comet turned into a collaborative endeavor, including not just scientists, but also amateur skywatchers. Astronomy is the foundation of this collaboration between experts and amateurs. It connected thousands of eyes on a single far-off traveler by reaching across the world with Atlas. The picture became evident when the data started to converge. Many voices were telling the narrative of a comet that had grown from a faint dot. Space observatories above the atmosphere, mountainside telescopes, and patient backyard astronomers all made contributions. The end effect was a symphony of perspectives, each contributing depth and richness, rather than a single point of view. The best science is rarely done alone. It is a team effort based on trust, patience, and collaboration. That spirit was expressed in the study of the 3I Atlas. The comet united a global community during its brief transit across our skies. It served as a reminder that learning is a collaborative process that involves sharing what we uncover and paying close attention to what we learn. Even if statistics are necessary, there comes a moment when they seem lacking. Equations, ratios, and magnitudes can all be used to characterize the orbit of the 3I Atlas. However, even while that information is accurate, it does not fully convey the visitor's experience. In order to properly understand it, we need to temporarily put the equations aside and adopt a new perspective. The experience of seeing a comet from another star is a simple truth that transcends facts and models. It is a storytelling point of light, a piece of a faraway world that has entered our sky. Although the facts are significant, they do not provide the complete picture. For many viewers, the experience of seeing something so uncommon is just as important as the lessons learned. The framework comes from science. Wonder and curiosity fill in the rest. To visualize Atlas clearly, picture it as an item that glows dimly in the night, rather than as a number on a chart. It appears as a faint blur via a telescope, encircled by a vague coma. A thin yet tenacious tail extends outward, constantly pointing away from the sun. Its brightness is faint and takes time to notice. Once located, however, it has a subdued presence. The comet appears diffuse, as if it carries its own atmosphere, in contrast to stars, which radiate with steady points. It progressively moves from one night to the next, shifting positions in relation to the starfield. This sensory portrait is what astronomers use to balance the data. There is no abstraction in the comet. Even if it is faint, it is palpable and perceptible. Atlas is a presence that demands deliberate, prolonged attention and is both a subject of measurement and an object of beauty. Atlas's hues speak for themselves. Depending on the filters employed, it appears pale, yellowish, or faintly green to the naked eye through the majority of small telescopes. When exposed to sunlight, molecules of carbon-based gases shine, giving the area its green tinge. Cameras are better able to catch the subtle colors, displaying a gentle golden in the dust and faint blues in the tail. These hues are more than just ornamentation. They are chemistry's fingerprints. Each one was connected to a particular grain or molecule. However, they also have a distinct significance. They serve as a reminder that this comet is a genuine object with its own light, not just a point in space. People are sharing a color palette that is carried across interstellar space when they post pictures of its dim glow. The chemistry of another system is depicted in the atlas's tints, which are momentarily displayed in our sky. Naturally, one would want to know what Atlas's nucleus looks like up close. It is not directly visible to us. The solid core is hidden by its coma, but astronomers can visualize it by comparing it to comets we have visited with satellites. It is probably gloomy, uneven, and pocked with cliffs and craters. Ancient dust would cover its surface, interrupted by gas escape valves. Past outgassing may have left some areas jagged and others smooth. Even if the nucleus is only a kilometer or two across, it is still a very small world. It does, however, have the record of its star nursery. It is not mere fiction to imagine its surface. It serves as a link between the actual physical body at the center of the faint fuzz we view from Earth. Silently, an alien world floated across space. One of the characteristics that sets 3I Atlas apart is its stillness. It emits no audible sound, vibration, or signal. It travels across the solar system without causing any disturbance to the surrounding vacuum. This quiet, however, is not meaningless. It is the quiet of time, of separation, of innumerable years spent in the voids between stars. The silence is a part of the experience for astronomers who watch it. Gazing at Atlas means gazing at something completely unconcerned, something that is unaware of our gaze. Its quiet is soothing and humbling. It serves as a reminder that, despite the vastness of the cosmos and the fact that not everything was created for us, we still have the means to recognize and value it. In this sense, the comet's quiet is an invitation to pause and think, not a sign of absence. Comets were significant in human culture even before they were recognized scientifically. Across civilizations, the unexpected sight of a comet was interpreted as a sign. They were seen by some as signs of impending catastrophe, famine, conflict, or the overthrow of monarchs. Others interpreted them as prophets, signifying significant shifts or messages from God. They had influence because of their erratic arrivals. Comets disrupted the order of the heavens by coming and going without warning, in contrast to the steadfast stars. They were depicted as burning swords or torches in the sky, even in literature and art. We are reminded by this history that comets are not only scientific objects. Additionally, they are cultural in nature, interwoven with our fears and stories. Even though Atlas is rare and interstellar, it follows this similar pattern. It also arrives unexpectedly, inspiring awe and significance as it goes by. Over time, specific accounts of comets as omens have been discovered. Ancient Chinese astronomers meticulously documented their appearances and connected them to shifts in the dynasty. As a symbol of the Norman conquest, Halley's comet was painted over the Battle of Hastings in Europe. Comets were a source of terror even in the 19th century, when their stories were believed to contain toxic gases. These tales weren't just superstitions. They were efforts to make sense of things that appeared to be out of human control. It was impossible to overlook a comet that was visible in the sky. It must have had some significance. The stories persist, even when we no longer dread them. They are woven into the cultural tapestry that influences our reactions. The old sense of awe returned when Atlas was proclaimed, but not the language of omens. There have always been layers to the human response. The distinction between myth and science is not always clear. Both start with seeing the unexpected and attempting to provide an explanation. Science employs data and models, whereas myth employed tales of gods and fate. However, both react to the same need to understand the sky. The overlap is obvious with comets. Spectra for chemistry are now provided by the same blazing tails that once evoked dread. Coordinated research endeavors are increasingly sparked by the same unexpected arrivals that seem to portend disaster. The fabled past is not erased by science. It expands upon it, turning dread into understanding. This transition is visible with Atlas. It is a visitor that arouses both emotional and intellectual astonishment, a comet that we can both measure and adore. Myth and science are two languages that convey the same meaning. Meaning is alive in the skies. The role of imagination in discoveries such as Atlas is subtle but significant. We can learn the orbit, chemistry, and brightness from the data. Its surface, its formation site, and the number of similar objects that might be drifting undetected are all further revealed by imagination. Additionally, imagination serves as a link between science and first-hand knowledge. Through a small telescope, it makes one feel as though they are part of another star system. It enables researchers to envision scenarios in which spacecraft intercept these tourists and return samples. Without creativity, the data would just be represented in charts. With it, the comet takes on the form of a narrative, an occasion, or an influence on the human mind. Atlas does more than just tell us. It arouses our curiosity by asking us to imagine what is out of our grasp. The visualization process is just as crucial as the actual measurements. We put the mathematics aside as Act the Eth comes to an end and sit with the greater significance. Yes, Atlas is a comet, but it also serves as a symbol. Its dim radiance in our sky serves as a reminder of the depth of the cosmos, as well as a physical phenomenon. It talks through its quiet, even though it lacks a voice. It bears the impression of another star but has no message. It combines information and creativity, science and culture, accuracy and poetry in its passage. Listening to Atlas allows one to experience perspective rather than sound. It serves as a reminder that wonder is just as important to discovery as data. We are reminded of our position in the cosmos when we stop to observe such a voyager. The silent act of paying attention can sometimes teach us more than the answers. One of the first lessons Atlas teaches is patience. The comet was delicate, dim, and easily obscured by the Milky Way's dense starfields. It took time to detect, time to take multiple photos, thoroughly examine them, and observe the small changes between frames. An interstellar comet's discovery serves as a reminder that some things cannot be hurried in a time of instant responses and quick outcomes. The cosmos has its own timetable. When the rarest things happen, it is our responsibility to watch, wait, and be prepared. There was not a single tremendous flash that revealed Atlas. Slowly it came out. Patience is the foundation of its story. That patience is more than just a habit for astronomers. It's a mode of perception. It serves as a gentle reminder to the rest of us that those who are willing to wait are frequently rewarded with surprise. The core of astronomy is meticulous observation, which Atlas emphasized. Neither random observations of the sky nor accident led to the comet's discovery. It was discovered by means of methodical surveys, accurate tools, and painstaking attention to detail. After it was spotted, its movement had to be verified by minute measurements taken night after night. Far from the thrill of headlines, this work is calm and deliberate. However, this discipline is precisely what transforms indistinct pixels into certainties. The discovery might have gone into question if it hadn't been rigorous. Atlas became a landmark with it. This is a straightforward lesson. Science develops by meticulous, consistent work as well as audacious notions. Finding meaning in the smallest glimmer of light and separating fact from fiction are made possible by the discipline of observation. Predicting what should happen is a common aspect of science. However, it also needs to be ready for anything unexpected. What a surprise Atlas was! Nobody had any idea when or what the next interplanetary object would look like. Astronomers, however, were prepared to adjust when it came. Research plans were revised, instruments were repurposed, and observation periods were altered. The scientific approach includes this flexibility. Sometimes, discovery deviates from the plan. Our ability to react and collect information before the opportunity is lost is put to the test by surprises. Atlas reminded the audience that mindset is just as important to readiness as technology. Anticipate the unexpected and be prepared to follow the evidence in order to deal with surprises in a tactful manner. Its resilience is demonstrated by science. Nothing unexpected disturbs it. It gives it energy, transforming astonishment into understanding. However, not all surprises should be regarded as sensational. Atlas also gave a restraint example. OMO's peculiar shape and absence of a coma sparked intense conjecture when it was discovered in 2017, including theories about extraterrestrial spacecraft. The painstaking science being done was overshadowed by the dispute. The reaction was more composed with Atlas. The information was unambiguous. This comet had a tail and was active, acting in ways that were recognizable. The impulse to exaggerate was resisted by astronomers. Without adornment, the importance was genuine enough. They avoided the traps of hype by maintaining the emphasis on the evidence. This equilibrium is crucial. Although they might draw attention, sensational assertions have the potential to undermine trust. Wonder doesn't have to be exaggerated, as Atlas proved. On its own, a comet from another star system is remarkable. There was more than enough truth to evoke wonder. Atlas's surprise is exactly what makes it so amazing. It was not anticipated, planned, or assured. Like all comets, it came abruptly, but with the extra burden of being interplanetary. Few astronomical phenomena can compare to the sense of rarity that this combination gave it. The unexpected is powerful. Routine is disrupted. It disrupts the sky's regular rhythm. It also encourages us to view the sky with new eyes. Atlas was not as spectacular as a meteor shower or a solar eclipse. It was inconspicuous, silent, and simple to overlook. But it was unique because of that very feature. It's not always the unexpected that shouts. The wonder lies in noticing when it whispers. Atlas tells us that even when we believe we understand the patterns of the cosmos, it can still surprise us. One of the secret talents of astronomy is transforming dim pixels into poetic expressions. The core of Atlas's discovery was a set of pictures, information, and spectral lines. These appear abstract and technical to the uninformed spectator. But a story comes out of them. Our solar system was briefly visited by a comet that was born around another star and ejected into the galaxy, drifting for billions of years. People are drawn to astronomy in part because of this shift from data to narrative. In addition to analyzing numbers, scientists also interpret them to create meaningful narratives that we can remember. Atlas evolved beyond a charted orbit. It evolved into a traveler, a messenger, and a transient visitor. The science is not superseded by the poetry. It emanates from it. We can determine it from the numbers. Imagination explains why it is important. When combined, they form the complete image. It is normal to envision the Atlas journey's start. A protoplanetary disk formerly orbited a newborn star in a far-off star system. It had clumps of ice formed by dust grains adhering to one another. One of these clusters eventually developed into the comet that we now refer to as Atlas. For millions of years, it might have orbited in peace until the gravity of a massive planet changed its course. It was thrown out in one final encounter. Its connection to its star was permanently severed. It was sent into interstellar space at that very moment. Its comet is gone and wandering, but the star that gave birth to it might still be shining somewhere in the galaxy. Visualizing that star gives our current view more depth. Atlas is more than a dim glimmer in our sky. It is a story that has survived for billions of years. Starting somewhere we'll never be able to go. Remembering previous visitors enhances Atlas's lessons. We learned that cosmic entities can take unexpected forms from the odd and silent Oumuamua. Some behave similarly to local comets, as Boris's brilliant tale showed. Atlas has now included a third chapter that attests to both familiarity and variation. These findings collectively paint the broad strokes of a larger picture. They serve as a reminder that while every visitor is different, they are all part of a greater population that we are just now starting to see. We learned patience, imagination, caution, and humility from previous guests. Atlas adds its own unique voice while carrying on that legacy. We can see the value of perseverance by studying all three. The story cannot be told by a single item. The only way we can expect to comprehend the galaxy's floating fragments is to collect lessons from many. Interstellar objects are a component of the cosmic census that astronomers talk of creating. Atlas helps with that census, which aims to count the travelers that move between systems in the same way that we count stars, galaxies, and exoplanets. Another piece of information in an expanding collection. The figures will show trends over time. What they are composed of, how frequently they occur, and what they reveal about their origins. Each one provides hints about the diversity of planetary systems, much like a survey form that the galaxy itself fills out. Although it is relatively small, the census is expanding. Atlas is more than just a singular incident. It helps us monitor the invisible flow of matter through the Milky Way and is a piece of a bigger jigsaw. It changes from a curiosity to a component of a broader body of knowledge in this way. We take a step back and put Atlas in perspective as Act 9 comes to a close. Although uncommon, it is not unique. Though weak, it is packed with meaning. Though short-lived, its lessons are timeless. It is data, spectra, and models for scientists. It serves as a reminder of our position in the galaxy to the rest of the globe. It informs us that pieces of other stars can and do penetrate our heavens, proving that our solar system is not isolated. It demonstrates that attentiveness is more important to discovery than spectacle. Although Atlas doesn't actively seek attention, it does reward those who do. From its vantage point, we can appreciate the universe's immensity as well as the value of close observation. In the end, it is a tale of connections between systems, between stars, and between the calm beauties of the sky and human knowledge-seeking. Above all, the tale of the three-eye Atlas is a brief one. It floats over our sky for a few brief months, giving us the opportunity to observe and discover. Then it will disappear into the darkness as silently as it came. Its beauty lies in its briefness. It is comparable to a casual friendship formed by a roadside stranger who exchanges stories before continuing on. Even if the interaction is brief, it makes an impression. Atlas enhances our understanding of the cosmos while it is here, but it is not here to stay. Its brief existence serves as a reminder that not all relationships are enduring. Certain moments of contact, which sparkle against the backdrop of eternity, are valuable precisely because they are fleeting. Atlas is a transient comet, and its meaning is found in that impermanence. Atlas serves as a reminder that the cosmos is more hospitable than it may appear. Even when stars are separated by light years, pieces of their systems may wander, come into contact with one another, and enter each other's sky. Neither our solar system nor any other is closed off. Throughout the cosmos, material is shared in infrequent but significant contacts rather than in large quantities. The idea that we are a part of a wider web is conveyed when a comet like Atlas passes into our line of sight. Other stars have made indirect contact with our heavens, causing material from them to collide with our planet. This area feels spacious and peaceful. However, it is real. Atlas is not a solitary entity. It is evidence of the interconnectedness of the galaxy, the fact that stars share more than just light, and the persistence of contact threads throughout the vastness of space. What occurs when Atlas departs? The solution is straightforward. It continues. It exits the solar system and returns to interstellar space because of its hyperbolic orbit. It will move into the dark, frigid spaces between stars, where it will continue to wander forever. It might continue to roam unchecked for billions of years. It might eventually pass near another star, where a different civilization would observe it and question its origin. But this is where the story ends for us. When it gets faint, our telescopes won't be able to see it. Though its chapter in our history will come to an end, the comet itself will endure. Its transit, not permanence, is what makes its visit so beautiful. A fleeting arc of light, then the silence that was before it. The data that Atlas leaves behind will endure even while Atlas itself will change. Each orbital calculation, spectrum, and image contributes to an ongoing archive. For years, scientists will examine these findings, contrasting them with those of other discoverers, honing hypotheses and looking for trends. Even though the comet will no longer be visible, its imprint will endure in our archives. The data might be thought of as the comet's shadow, a trace that has been left behind for others to find. The object will continue to teach scientists even after it is gone. The trajectory will be compared with that of new visitors, the chemistry will be re-examined, and the raw numbers will be reanalyzed. Atlas will become a part of the expanding interstellar object catalogue. Its presence persisted in understanding rather than light. Atlas's finding also sows seeds for the future. The argument for planning missions to intercept interstellar visitors is strengthened with each one. Consider a spacecraft that is ready to take off when the next object shows up. We could send sensors to fly alongside with enough notice to directly sample the gases or perhaps bring material back to Earth. This was no way to get to Atlas. It was discovered after the fact. However, it gives such missions more hope. The comet serves as a reminder that these are actual, not merely speculative, opportunities. With sufficiently sophisticated technology, the next visitor may be located early enough to establish contact. Even while Atlas may die in peace, its memory might serve as an inspiration for the instruments that will eventually enable us to grasp a piece of another star system. There may be more to come if 3 interstellar objects have been discovered in less than 10 years. Atlas is not unique in its existence. It is unique in its visibility. Such wanderers probably abound in the galaxy, innumerable pieces floating invisibly. We might find them more frequently with better surveys. Everybody is contributing a piece to the puzzle. Atlas demonstrates this future's promise. An increasing catalogue can be attributed to its behavior, chemistry, and orbit. We will see trends as the list grows and possibly even determine the types of stars that are most likely to bring us visitors. It is not conjecture that there will be additional interstellar comets. It's expected. Atlas is a start, not a finish. An indication of the numerous travelers who are still to be found. Every new discovery, such as Atlas, modifies our maps of both space and mind. There had never been any confirmed interstellar objects before 2017. We must now reinterpret how solar systems fit into the galaxy in light of the 3 examples that are currently known. In addition to the planets, asteroids, and comets that are confined to the Sun, our charts now occasionally depict extraterrestrial visitors. These guests serve as a reminder that the solar system is interconnected, open, and permeable. They go beyond what we think of as local, demonstrating that the galaxy is a site of exchange rather than a faraway background. Atlas broadens our understanding by identifying the solar system as a stop along the larger currents of cosmic matter rather than as a closed system. Without depicting the routes taken by these rovers, our maps would never be complete again. Just as significant as the facts is how people react to Atlas. It is an opportunity for astronomers to research, publish, and improve theories. It is an opportunity for the general public to be in awe, to gaze up and dream. Atlas's news was received with silent awe rather than panic. People followed the story, asked questions, and contributed pictures. The sight of an interplanetary comet provided a moment of perspective in a world too frequently preoccupied with pressing issues. It served as a reminder that the cosmos is big and full of surprises, and that there is more to life than what we experience every day. The significance of discovery lies in the human reaction in all its manifestations. The comet would still pass without it, but nobody would notice. Atlas joins our collective history with it, a tale that is recalled long after the light has gone out. The moment will eventually arrive for a private farewell. Atlas will fade into the distance and disappear from view. After one final recording by telescopes, it will vanish. Just the conclusion of a section, with no fireworks or spectacle. Bidding farewell to such an item evokes a range of feelings. There is grief that it won't come back, but also thankfulness for what it showed. However, there is also acceptance. Interstellar comets are much more of a nomad. We are not allowed to keep them. They go through. They serve as a reminder of the galaxy's vastness before moving on. The experience includes saying goodbye, a reminder that beauty is frequently ephemeral. Atlas will go from us, but not before leaving us with a deeper understanding of the world and a wealth of information. We tracked the path of one of the rarest discoveries of our time, a comet from another star, and an interstellar traveler tonight. We've witnessed its discovery, its chemistry, its ability to transport us to far-off regions of the Milky Way, and its ability to remind us of the silent wonder that exists in the night sky. In addition to providing information, these tales are meant to soothe you to sleep with curiosity as a kind companion. I encourage you to like, subscribe, or leave a comment if you found this exploration enjoyable. It enables us to connect with more inquisitive people and permits these explorations to go on. But for the time being, allow the image of far-off comets to gently float through your mind. Sleep is waiting, the night is quiet, and the universe is vast. Rest well until the next time.